Section 3.3, product and quotient rule in higher order derivatives. Let's take a look at the product rule. Okay, it states here the product of two differentiable functions, f and g, is itself differentiable. Moreover, the derivative of f times g is the first function times the derivative of the second function plus the second function times the derivative of the first function. So this right here is stating what this is stating down here. Okay? If we take the derivative of the f function times the g function with respect to x, the rule is it's the first function times the derivative of the second function plus the second function times the derivative of the first function. So that's the rule. We're going to go through the proof of this rule to see where it comes from. This is, again, another proof that I definitely could ask you to reproduce on the next test. So make sure that this makes sense. Okay. So, as all of these proofs, we're going to start with the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0. This is the definition of the derivative of f of x. We should be very familiar with this. Now, notice here, for this one, we're no longer taking the derivative of just f of x. We're taking the derivative of f times f of x times g of x. So, what's going to go here on this first line, it's going to be the limit of f of x plus delta x times g of x plus delta x minus f of x times g of x all over delta x as delta x goes to 0. Hopefully that makes sense, how we're going from this derivative to this one. Because the function of this one is just f of x, the function of this one is f of x times g of x. Okay, so that's step one. Step two, when we take the derivative with respect to x of f of x times g of x, everything from step 1 to step 2 is going to be exactly the same except what I have here highlighted in red. If you notice here, this negative f of x plus delta x times g of x plus f of x plus delta x times g of x, that is, if we would add those together, since they're opposites, that's just a fancy way to write 0. Okay? Alright, step 3. Now what we're going to do, okay, right here, so what I've got in these blue brackets here, I'm going to factor out f of x plus delta x. If I do that, I'll be left with g of x plus delta x minus g of x all over delta x. Still going to have the limit as delta x goes to 0. And then over here, in red, these brackets here, I'm going to factor out g of x. So I'd be left with f of x plus delta x minus f of x all over delta x. Okay, g of x would be out in front. Okay, and then I'm going to take the limit of each of these as delta x goes to 0. Okay, now step 4. now I'm just going to evaluate the limit. So as delta x goes to 0, this part of the limit here, that's just going to become f of x, because delta x is going to go to 0. And then this right here, if I take the limit of g of x plus delta x minus g of x all over g of x, or delta x, as delta x goes to 0, hopefully you can see that that's equal to the derivative of g of x. Just like this would be equal to f prime of x. Okay? Plus, okay, if I take the limit of this g of x as delta x goes to 0, since there's no g of x in the function g of x, this would just end up being g of x. And then when I take the limit of f of x plus delta x minus f of x all over delta x, as delta x goes to 0, this is the definition of the derivative of f of x. So this is stating the rule. That's the proof. Let's try some of these. Example 1, let's try to apply the product rule. So again, we're going to use the product rule when we have two functions that are being multiplied together and we want to find the derivative of the whole thing. So again, the derivative of f of x times g of x with respect to x is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, and again, this is another way. Okay, so we've got all of this. And if we look at this particular problem, I'm going to say that this is f of x. I'm going to say f of x is equal to 3x minus 2x squared. And I'm going to say g of x is equal to 5 plus 4x. So this is just equal to h prime of x. Right? That's the derivative of this whole thing. So let's see if we can solve this. So f of x is just equal to 3x minus 2x squared. G prime of x, if I take the derivative of g of x, that's going to just be 4, plus g of x, well, g of x is 5 plus 4x. F prime of x, if I take the derivative of f of x, that's going to be 3 minus 4x. And now we're just going to simplify. So I'm going to multiply the 4 through here, giving me 12x minus 8x squared, plus, let's see, 15 minus 20x plus 12x minus 16x squared. And then I'm just going to combine like terms. So negative 8x squared and negative 16x squared would be negative 24x squared. Let's see. $12x and 12x would be 24x. Minus 20x would be 4x. And then plus 15. This would be our answer. Okay, let's try one more of these. Find the derivative of y equals 2x cosine x minus 2 sine x. So here you can see that we have two functions being multiplied together. So again, just for this part, we need to use the product rule, where I'll say f of x is equal to 2x and g of x is equal to cosine x. Again, when we're taking the derivative of f of x times g of x with respect to x, it's going to be the first function times the derivative of the second function plus the second function times the derivative of the first function. Okay, so let's go through and see if we can do this. So we're going to say y prime is equal to f of x, which is 2x, times the derivative of g of x. Well, the derivative of cosine of x would be negative sine of x, plus g of x, which is cosine of x, times the derivative of f of x, which would be 2. So that takes care of this piece, minus 2 sine x. So now I got to take the derivative of negative 2 sine x, which would be negative 2 cosine x, because the derivative of sine x is cosine x. So now let's see if I can clean this up a little bit. Let's multiply here. This would be negative 2x sine x plus 2 cosine x minus 2 cosine x. Here you can see that 2 cosine x minus 2 cosine x, those cancel out, so you'll have y prime equals negative 2x sine x.